Hi guys. Okay, we're going to talk about probability distribution today. And basically, it's just a way to show the probability of something happening. Okay. Um, there are two things that we need to look out for on probability distribution in order for it to be a true probability distribution problem. Um, like I said, it is a visual representation. So usually in a table, a chart, a graph, we'll see a lot of tables in this course Algebra 2. But there's going to be two things that happen on this table or whatever they're using to represent it. We're going to have the possible outcomes, which is going to be capital X in most cases. And then we're going to have the probability of each thing happening. So let's take a look at our first example. All right, so consider the sum of two dice after being rolled. What is the probability distribution of this event? So we want to take into consideration all the possible outcomes for this. So what we're going to do is we need to think about. So our table, our probability distribution table is going to look like this, where we're going to have x and the probability of x. So first we have to figure out what the heck are our options. These are going to be all the possible outcomes, x, right? So what are the options when we roll some dice? So let's look at this. So we can get 1, 2, 3, 4, 5, 6 when we roll the first dice, right? If we roll the second dice, we could get the same thing. 1, 2, 3, 4, 5, 6. Okay, so these are the options on our dice. We're taking the sum of these guys because it says right here, the sum of two dice being rolled. So now we need to figure out, okay, if I rolled a 1 and a 1, what would the sum be? Well, the sum is 2, so I put a 2 in there. If I rolled a 1 and a 2, my sum would be 3. If I rolled a 1 and a 3, so on and so forth. 1 and a 4 is 5, 6, 7. So now let's say I rolled a 2 and the second dice was a 1, the sum would be 3. Okay, so we just go ahead and fill this all out. So we're going to get 2 and 2 is 4, 2 and 3, 5, 6, 7, 8. 3 and 1 is 4, 3 and 2 is 5. And just keep filling that out. 4 and 1 is 5, 4 and 2 is 6. And if you can see the pattern that it goes on, it starts one number higher, so 5 and 1, that's 6, and then these keep going up by 1. So it's kind of a neat little trick to not have to fill it in so slow by actually taking each individual sum. It's just a nice little pattern that this guy has. I think that might be why they use it so much in statistics, is just because it's not hard to come up with your, what is this called when we list all the possible outcomes? Sample space, remember? So okay, so we have our lovely little possible outcomes here. We want the probability distribution for this event. So looking at these are the numbers on the side of the die, so they don't really care. These are all the sums, right? So these are the ones we care about. This is going to be our x variable. So what options do I have? It looks like I got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Are there any other options? I don't think so. So these are all of the options for for x is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I were to roll two dice and add them together, these are the only options that I could possibly get. Okay, so now we got to figure out what is the probability of each of these things happening. So out of all of these rolls, how many of them are going to be a sum of 2? So look over here. I only have 1. So it's going to be 1 of how many options are there? So there's 36 options, but let me show you. So you could count them all, or we could just say, okay, we got 1, 2, 3, 4, 5, 6. 6 options times 1, 2, 3, 4, 5, 6. 6. Remember the Counting principle rule, you multiply the number of options by the number of options. So on dice 1, we have 6 options. On dice 2, we have 6 options. 6 and 6 is 36 options. All right, well, how many of them are 3? There's 1, there's 2. There's 2 3s. And then 4s. 1, 2, 3. 3 4s. 5. 1, 2, 3, 4 5s. 6. 1, 2, 3, 4, 5 6s. 7. 1, 2, 3, 4, 5 6 options. And then if you can see, now it's going back down, like in the triangle, like this is the longest part, right? And then the next one's going to be 1 less than that 6. So we get 1, 2, 3, 4, 5. What? 5 options. And then I bet the next one's going to be 4 because this number's going to start going down. So let's see. 1, 2, 3, 4. What do you think the next one's going to be? 3. But if you can see the pattern, we go up to 6 and then we're going to start going down to 1. Okay. Okay. So is this a probability distribution? Let's look at our 2 options. Does it give you all the possible outcomes? It sure does. Here are all the possible outcomes for my sum. Does it give you the probability of each one happening? Yep, it sure does. Okay. The other thing that probability distribution will always have is the sum of the probabilities. So if I were to take all of these guys and add them up, my sum is always going to be 1. Why? Because these are all of the options. This is 100% of the options that I could possibly get by rolling 2 dice. Okay, so your sum will always be 1, aka, whoops, you can't see that, aka 100%. Okay, so looking at this chart that we have over here, this is my lovely chart for probability distribution. Okay, so let's go ahead and find, let's go ahead and say, what is the probability that you get a sum more than 10? Okay, so what options are greater than 10 for your sum? 10 is 10 greater than 10? No. But 11 is greater and 12 is greater, right? So the options of getting a sum more than 10 would be 2/36 and 1/36. We're going to add those 2 guys together, so we get 3/36, and then of course we'd always want to reduce. If you wanted to put it into a percent, let's find out what that percent is. I get 0.08333, so I can say 8.33%. Okay. Okay, let's try one more. What is probability the sum is between 5 and 7? Okay, so what is the sum probability that the sum is going to be between 5 and 7? So we gotta kind of think. Sorry, make that a little less blurry for you. There you go. We gotta kind of think: is this mean? Is this including 5 and 7 or not? So, like, let's think. If you try to think of an example. If you're at a fair and you have to be between the ages or between the height of 60 inches and 65 inches in order to go on this ride and be safe. Can you be 60 inches and go on? Yes. Can you be 59? No. So this one would be inclusive. So it would be including these guys. Okay. So now we're going to go back up to our table and look at the probability of between 5 and 6. So we're going to look at this guy, and this guy. Okay. So then when we're going to add those, we got 436, 536, and 636. Sorry, I'm trying to get all in there for you. Okay, so we have 436 was our first one. Doesn't matter the order. And 636. So if we add all these together, 5 and 4 is 9, and 6 is 15. 36th, which does reduce. Remember there's that little rule, like if, I don't know if you guys know this or not, if you add the digits together and that number is divisible by 3 or 9, then 3 or 9 goes into that. So 1 and 5 is 6, 3 is divisible by 6, so 3 goes into 15, which is 5. And then 3 plus 6 is 9, 3 goes into 9, so that's 12. So it's just a quick little cheat for seeing if something is divisible by 3 or 9. Because 3 and 9 can kind of be hard. Like when you originally look at this, oh, it doesn't reduce, but it sure does. Okay, I think that is it for probability distribution.